Let's think about the change in energy as we rotate about the carbon-carbon single bond of ethane. We're going to start out in the eclipsed conformation, and we'll focus on two hydrogens that have arbitrarily been colored red and blue. To start with, the red and blue hydrogens have a dihedral angle between each other of 0 degrees. We're in eclipsed form, so we know this is the higher energy form. Let's begin. The first rotation will be 60 degrees. This changes the molecule from being in an eclipsed form, higher energy, to a lower energy, staggered form. If we do a further 60-degree rotation in the same direction, we end up with a total rotation now of 120 degrees. We go from the lower energy stagger form back to the higher energy eclipsed form. Another 60-degree rotation goes from a total rotation of 120 degrees to now a total rotation of 180 degrees. We've changed from the high energy eclipsed form back down to the lower energy staggered form. Another 60-degree rotation goes from a total rotation of 180 degrees to a total rotation of 240 degrees. We change from the staggered conformation back to the higher energy eclipsed conformation. Yet, you're getting tired of this, right? Another 60-degree rotation. This takes us from total rotation of 240 to total rotation of 300 degrees. We're now changing from the higher energy eclipsed form back down to the lower energy staggered form. Let's just keep going one more. The final 60-degree rotation. Okay, we now have a total rotation of 360 degrees. We've gone all the way around for our red and blue hydrogens. We've now returned from the lower energy staggered form to our higher energy eclipsed form. And the red and the blue hydrogens again have a dihedral angle of 0. So we're seeing higher energy and lower energy. But what's the difference between the two? Well, we know in the eclipsed form we have 3 torsional strain influences. Each constitutes 4 kilojoules per mole, so 3 of those gives us 12 kilojoules per mole. We've talked about the gauche effect adding extra stability, lowering the energy of the staggered form. But here that effect probably is very minimal, so we're going to discard it for the moment. So in total, we have approximately 12 kilojoules per mole between the eclipsed and staggered forms of ethane. Because each staggered form is the same energy, we would expect the populations to be similar. Each staggered form should be of a ratio 1 to 1 to 1, whether it's at 60 degrees, 180 degrees, or 300 degrees in total. The same is true for the eclipsed forms. It doesn't matter because they are of the same energy, so we should expect the same number in their population. They're of a ratio of 1 to 1 to 1 yet again.